the difference between binomial and geometric. Binomial indicates that you have a fixed number of trials. And so how to tell the difference between the two is that if it says out of 10 rolls, out of 5 cars, out of 10 children, then that's going to indicate that you have a binomial distribution. Geometric doesn't give you a fixed number of trials, but the key wording for geometric is it's going to say when does the first success occur. So it could have an infinite number of trials, but geometric means that you're going to keep going until you hit that first success. So like, what is the probability that you have a girl on the 5th child or something like that? So you're going to keep going until you have a girl. So the same properties as binomial in that you have 2 mutually exclusive outcomes, like you have a success and you have a failure. So you either have a boy or a girl. There's 2 mutually exclusive outcomes. The second is that each trial is independent. So within one trial, you have 2 mutually exclusive outcomes. And I think this is a hard concept for people to understand. So within one trial, like if I zero in on one trial, I have 2 outcomes, boy or girl. Then what it means to be independent, each trial is independent of others. What that means is first child, second child, third child, fourth child, all 4 of those children, the outcomes of those are independent of one another. So whether I have a boy or girl in the first child does not affect whether I have a boy or girl in the second child. So like just because I had a girl as my first child does not change the probability of boy or girl for my second child. So each trial is independent of each other. Probability of success is the same for all trials. So that means that my probability is not changing. So second and third bullet kind of go hand in hand. And then this is what is different. With binomial, it says fixed number of trials. Like I'm going to say out of 10 people, out of 5 rolls, something like that. Geometric is the number of trials until the first success is observed. So when you're doing a binomial distribution, all of the possible values are, they start at 0, and then they go to your fixed number of trials. With geometric, the possible values must start at 1, and then they go to infinity. So that is how it's different when you're setting up a binomial versus a geometric. So we're going to look at some problems to show you kind of how to, and honestly, it's easy to differentiate between the two. Because with geometric, you only type in 2 numbers, and with binomial, you type in 3. This is the formula. You won't ever need this, except for the fact of if you see a multiple choice question and it asks you to plug in the formula for that, like plug in what P is and what X is. And so X represents the number of trials that it's indicating, and P represents the probability. So suppose that 405 of the students who drive to campus at your school or university carry jumper cables. Your car has a dead battery and you don't have jumper cables, so you decide to stop students as they are headed to the parking lot and ask them whether they have a pair of jumper cables. Let X represent the number of students stopped before finding one with a pair of jumper cables. Why is this geometric and not binomial?
Because you stop and get the jumper. There's no fixed
yeah,
numbers.
like there's no fixed number. I stop whenever I find somebody with jumper cables. So what is considered success is when I find somebody with a jumper cable. Then I can stop. Why does it not start at 0?
It's not a trial.
Like you can't stop 0 people and find jumper cables. You have to stop at least 1 person. And it could be the first person that I stop that has jumper cables and then I stop. Or it could be 50 people. So there's no right or wrong answer. You just keep going until you find the person with jumper cables. So yes. The probability of finding somebody with jumper cables is 40%. So I guess according to the school or university, 40% of the people have jumper cables in their car. What is the probability that the third student stopped will be the first one that has jumper cables? So this is what it looks like if it were plugged into the formula. But I'm going to show you how to do it in your calculator. So go ahead and get your calculator out. when it says the third student right here, so that it is exactly the third student, that indicates that it is a PDF. Like, it's saying that the third person I stop is the first one that has jumper cables. So you would say the probability that x equals 3. You would do geometric PDF. And so to do that, you go to second vars and then geometric PDF. You scroll down.
It's E.
T?
E.
E. Second vars E. And then it's going to prompt you to put in the probability. Then it's going to prompt you to put in the x value. So in this case, it's saying is the third. So you would put in 0.4, comma, 3.
They said you have to use 3 numbers on geometry.
On binomial, you use 3. So whenever you use your calculator, it's going to be easy to decide whether you do geometric or binomial. Because let's say that you accidentally did binomial PDF, you would get stuck. You would be like, what do I use for the last number? I don't have a fixed number of trials. So hopefully he would then recognize that you can't do binomial. It would have to be geometric. And anytime you see the word first, which is going to show up in almost every single geometric problem, you see the word first, that's going to be a big indicator that you're doing geometric and not binomial. So when you type that in, you should get 0.144.
We have to rate it out like that, right?
Yes. This is what I would be looking for.
What if you solve the other way?
You could.
We have to rate out.
You would show it plugged in. So this would be like something you would see on a multiple choice where it would give you 4 answer choices and they would look something similar to this. And you would need to know the formula like 1 minus p to the x minus 1 times p. Mm-hmm. Yes.
How is this different than what we did like 2 chapters ago with probability? Or what are the odds that the 4th child's a girl? And then we did 0.5 to like the 4th.
This is the same concept, but it kind of goes back to that light bulb example where it said like, what's the probability that exactly 1 is defective? There are ways to do it, but there's so many options, especially when you have, 10 children that you're looking at. You have to look at every single scenario. So this is just a shortcut way to kind of do it on the calculator versus like thinking of every single scenario. But in this, like geometric, it would be easier to do it by hand. Binomial is a little bit more difficult. Okay, the next type of question, what is the probability that at most 3 students are stopped before finding one with jumper cables? So this would be an instance where you see a CDF because it's at most 3. So that would mean the probability that x is what? Less than or equal to 3. So you would do geometric CDF. So the same rules apply of the CDF, the 1 minus CDF, all of that all still applies. It's the same rules as binomial. The only difference is that you're using geometric instead of using binomial.
How do you find this without using the CDF?
I'll show you the formula here in a minute. And what do you get when you plug that in? 0.74.
0.784.
0.784. Thank you. So this is less than or like this means that what is the probability that the first person, the second person, or the third person have jumper cables? Whereas the other one is just saying the third person. If you were to do this by hand, you would have to do like the formula that you see right here. You would have to do it for x equals 1, x equals 2, and x equals 3. You would have to add those together. So you'd have to do it 3 times. So that's why sometimes doing it by hand is more difficult. It would be like doing a geometric PDF for 1, 2, and 3 and adding those together. Yes?
If you ask a question about like parents that have diabetes, would that be like genetic? Or not genetic, independent?
Any type of question like this is going to be independent. You don't have to check.
Okay, so like if it's like a disease that's genetic.
If it gives you a probability, then it's going to be independent. Like if it says the probability of getting this disease, like getting chickenpox, is 23%, then that's going to be an indicator to you that it's independent.
But what about diabetes?
I don't know.
It's a good question.
It is.
Okay, these are the calculator rules. We kind of already went over that.
Unless obesity runs in your family.
Count the number of boys in a family of 4 children. Would this be binomial or geometric? Binomial, because why?
Because it's just counting. It's fixed number.
Because of the fixed number of trials. So if I have a family of 4, if I have 4 children, that indicates that it's binomial. So on a free response for this test, I'm going to give you one scenario. I'm going to ask you binomial and geometric questions mixed in. They're going to be scattered throughout. I'm not going to say this is a binomial situation, this is geometric. I'm going to give you one scenario. I'm going to say the chances of getting chickenpox is 23%. And then I'm going to ask you 10 questions about it. Some are going to be binomial and some are going to be geometric. So you have to be able to differentiate between the two. And then the second one, count children until first son is born. What kind would that be? Geometric. Good.
Are we gonna get a quiz back?
Yes, once everyone takes it.
So basically until
So what is the probability that the first son is the 4th child born? What calculator would I do?
Binomial. Wait.
Oh, I know.
I know.
That's geometric. That's geometric.
Geometric because of what?
We don't have. Oh yeah, the first.
Oh, well then you can just pay attention.
So it's not just not.
Okay, geometric.
So.
So,
It's geometric.
geometric what?
PDF.
And the probability of having a boy is 0.5. And you would put 4 here. What is the probability that the first son is at most the 4th child?
Geometric.
So it would be less than or equal to 4, which would be geometric. CDF, 0.5, 4. What is the probability that the first son is at least the 3rd child? So that would be X is what?
Greater than or equal to 3.
So 1 minus geometric.
CDF 0.5. Oh wait.
And what goes here? 2. Because if you think, remember drawing out the number line, you're going to have 1, 2, 3, 4, 5, all the way to infinity. If it's at least 3, I want to include 3 and everything above it. So 1 minus geometric CDF, and I want to take away 2 and below. But I want to keep 3. So don't put 3 here. You put the 1 below because you want to hold on to 3. Because saying that greater than or equal to 3 is the same as saying greater than 2. So if you want to write it this way, that might help you when you're putting in the second word, in the second number. So these are what it would look like. So the formulas for mean and standard deviation of a geometric. These you do have to memorize. Why the formula chart gives you binomial and not geometric is unclear to me, but you do have to memorize.
A petition.
I don't think we have.
Okay, then write these down. I think that I did not include the last page of the PowerPoint. It's not in there. So write these down. You must memorize. So the formula chart for the AP test gives you binomial, mean, and standard deviation, but it does not give you geometric. So you do have to memorize these. I don't know. I just said I don't know why.
Can you just add it?
No.
What's the final exam look like? 'Cause you
Multiple
write it, right?
choice.
Is it hard?
It's fair.
You can't exempt it.
Is there a curve?
Yeah, Wait, is there a bonus? You can't exempt it.
Yeah, you can exempt it if you hit terms, right?
Okay, does everyone have this written down? Mean is 1 over p. Standard deviation is the square root 1 minus p over p squared. So, a real estate agent shows a house to prospective buyers. probability that the house will be sold to the person is 35%. What is the probability that the agent will sell the house to the third person she shows it to? What would I do here?
35 times 35 X.
Is it geometric or binomial?
Binomial. No,
Pro-
it's
Geometric, because it doesn't give me a fixed number. So, probability that it says to the third person, so X equals 3. Geometric, PDF. Probability is 0.35. Oops, didn't need to do that. And 3. Then the question where you would need to do mean and standard deviation, it says, how many prospective buyers does she expect to show the house to before someone buys the house? So how many houses is she going to have to show before she expects to actually sell it? So for mean, you would do 1 over 0.35. And then the standard deviation is the square root. 1 minus 0.35 over 0.35 squared. Yes, Drew?
Am I saying expect in that question that shows that we need to find?
Mm-hmm. Because the expected value and mean are the same thing. So, and even though you get a decimal and it doesn't make sense to show 2.86 houses, you still leave it as a decimal. So don't change it and round up or round down. Don't say about 3. Just leave it as 2.86. Same with standard deviation. Okay, some properties of the geometric, and I'm going to make us a little T-chart that talks about the differences between binomial distributions and geometric. So if you look at this is supposed to be an activity, but I'm skipping it. So as your probability is increasing, so think about this as being the probability of shooting a basketball and making it into the hoop. So let's say that, Courtney, you have a 10% chance of making the basketball shot. And then it's going to take longer. So imagine this. It's going to take longer because geometric is how long it takes to get the first success. So it's going to take a little longer for Courtney to make the basketball shot because she only has a 10% chance. Then she decides to diligently practice every day for 5 months.
Oh my, that's
And here we are
and then I made the
with a 90% chance. You increased your percentage. You increased your percentage 80% in 5 months. And so now I expect that it won't take you as long or as many shots to make the basketball in the hoop now as opposed to when it was 10%. So if you can kind of imagine what the graph is doing, it's going to take you longer when you have a lower probability. And if you have a really high probability, you're probably going to make the basketball shot in like 1 or 2 shots. But when you only have a 10% chance, it's going to take you 5, 6, 7 times maybe. So as your probability is increasing, there's a few things that are happening. The histogram shifts to the left and the shape becomes more and more strongly skewed right. So I don't want you to write this down now. I want you to, in a minute, we're going to flip the page and you're going to have I think there's like a blank space on the back somewhere. There's no, you already have it in your notes. This is for geometry. Maybe find a blank page that we can write. I think past the binomial worksheet number 2. There's like a little, we're going to make a little compare contrast of binomial and geometric distributions.
I love those.
As the probability of success increases, the mean decreases and the standard deviation decreases. So it's not like you go until 0.5 and then you increase again, kind of like the binomial one. They both decrease. The mean gets smaller and the standard deviation decreases as well because it's getting more compact. So flip to, I guess there's like a page on the binomial worksheet number 2. What page is that?
265.
265. So go to page 265. This is ugly. Binomial and geometric. Yes?
Can you already make a T coordinate?
Sure. Okay, binomial in geometric, and we are going to compare and contrast the things that happen to the graph.
His brain is
Mm-hmm.
I thought the ornaments originally, weren't they like a drop quiz grade? I was kind of thinking about that.
No.
Let's keep talking
I
about
thought
something.
that was it. I
No, we're not talking about, we are on video, we're not going to talk about it.
sworn she talked about it.
Mm-mm. Okay, for binomial, so this is all in the case of which the probability of success is increasing. So you can write in the middle as probability increases. So think about a 10% chance of something happening versus like 10% to 90%. Think about the basketball scenario. You have 10% chance of making the shot versus a 90% chance of making the shot. For binomial distributions, as it's increasing, so as Courtney is practicing basketball for 5 months, for binomial, the histogram shifts right and it goes from a right skew to a left skew. So it's kind of going to the right. It starts off as a right skew like this, and then it goes to a left skew. It's a beautiful picture. Geometric. So for geometric, it is shifting left. And it's already a right skew, but it gets more and more right skewed. So it's just strengthening the right skew. So it kind of starts off like as this, and then it goes to that. Beautiful pictures.
Is it always true?
Yes. For binomial distributions, the mean increases. For geometric, the mean decreases. For binomial, the standard deviation increases until P equals 0.5, then decreases. So it's kind of symmetrical. And then for geometric, the standard deviation decreases. For the formula for mean for binomial, mean equals n times p. For geometric, mean equals 1 over p. So if you think about it, like if you know the formulas, you can think about that logically. If my p is increasing for binomial, the value is getting bigger, but if my denominator is increasing, the value is getting smaller. For standard deviation, the formula for binomial is np1 minus p. For standard deviation for geometric, 1 minus p over p squared. So think about that. If my p is increasing, my denominator is increasing, and that's causing the whole thing to get smaller. These two you are given. These two you must memorize.